for this, definitely. Hopefully I told you to borrow one from school today, and I hope you bring it back tomorrow. Alright, so let's start this. Now, compound, right? Not this one, that's simple interest. It's just like too easy, right? But this one we know how to use, and this is compound. So the compound is a little bit different. Let's say you deposit $4,000, pay 6.3% annually, not annually, quarterly, so every 3 months. How much money is in the account after 21 years? Well, so we're putting 4,000 down. 1 plus 0.063 divided by compounded quarterly, so that's 4 times a year. And this is 4 times 21, which I'm going to change to 84 right away. Okay, so this is what we're working for. So, all right, once we put our numbers in, it's just, like I keep saying, an exercise in your calculator skills. So, first thing we have to do is inside the parentheses, so order of operations speed. And we're going to divide 0.063 divided by 4. And you're going to get a number in your calculator, and I'll put it over here on the screen on top. To that, we're going to add plus 1. And you're going to keep your calculator there, and you should have this in your calculator. And now use this button next, right? Yeah, press that one, and then we're going to press 84, and then click enter. And we're going to get A equals, sorry. So we raise it to the 84th power, and then that number there in your calculator should look like this. We're going to multiply that, and again, hopefully you'll just press multiply times 4,000. And your account, after 21 years, is going to have 21 years, 14,864.61 cents. All right, that's how much your account is going to have, and that includes your $4,000. So you made about $10,000. Okay. And we're going to repeat the process quite a few times. Same thing here. So we're depositing 6,500. 1 plus 0.08 compounded monthly, so we're going to divide that by 12. Over here it's going to be n times t, right? The number of times compounded times the number of years, so it's 12 times 13. 12 times 13 is 156. So this is what we're working with. Again, inside of parentheses, let's divide first. 0.08 divided by 2, well, 0.04, to which, sorry, not divided by 2. 0.08 divided by 12, you're going to get a repeating decimal in your calculator. Leave it, and you're going to get a bunch of 6s and a 7 at the end. To that, we're going to add 1. Your calculator should state this number, 1.00666, and a bunch of 6s. Okay, and then the last 7. And then we're going to then raise it to the 156 power. So I'll press this button, read to 156 power, and we're going to get A equals 6,500. And inside parentheses, finally, we get a single number, 2.819469267. And then we're going to take that and multiply it by 6,500. And your account is going to say $18,326.55. And that includes your 6,500 from the beginning. Okay. 3. Now, 3 says I have 45,000 in my bank account. I don't know how much I've deposited, so let's keep that P over here. Right, that's my unknown. It's going to be 1 plus 0.09 divided by, what is this, compounded monthly, so 12 times a year. And here it's going to be 12 times 6, which I'm going to change to 72. Alright, so this one's a little tricky. No, actually it's not, sorry. Let's find a parentheses, so 45,000 equals P, and let's figure all this stuff is. So 0.09 divided by 12 equals 0.0075. We're going to add 1. And in your calculator, you should have this. We're going to raise that to the 72nd power. So press this and then 72. And we're going to get 45,000 equals P, and this number is going to be 1.712552707. So I'm going to use all that. We're going to divide that by the same number, right? 2552707, and on the other side we're going to divide by the same 2552707, and P equals, so I'm going to enter, now you're going to have to clear your calculator, 45,000 divided by 1.712552709. It means that you started your bank account with $26,000, 276.56 cents. So that's how much you put in your bank account. So it's not much. I mean, it's still nice, right? But it's only because it's only 6 years. Okay. 4, if you deposit, how much money will be in the account? So we're back to looking for A. That's our unknown. So we're going to put 4,500 in the bank account. 1 plus 0.05 compounded yearly. So there's only compounded once a year. And here is going to be 1 times 10. Or just simply just write 10. So this one. All right. Again, 0.05 divided by 1 is just 0.05. We're going to add 1 to that. So we get 4,500. Oops. And then, sorry. Take that back. Take back what I said. So right now in your calculator, you should have this number, 1.05. We're going to raise that to the 10th power. And now you're going to have 1.628894627 in your calculator, which you're going to be multiplied by 4,500. And that gives us our balance after 10 years. So multiply times 4,500. And in our account in 10 years, we're going to have 7,330.02. 03 actually. Okay. 5. How much money do you need to deposit? So P again is our unknown. So if you want to have $70,000 at the end of 9 years, how much money do I need to deposit initially? 0.056 compounded monthly, so it means 12 times, and there on top is 12 times 9, right? The number of years times the number of times it's being compounded, and that's going to be 108. All right, let's simplify that parentheses. So 70,000 equals P and all that. Let's see, so 0.056 divided by 12, enter, plus 1, enter. So we're going to have this huge number, 0.046666667. We're going to raise that to the 108th power. So press this button, and then 108, enter. So all that becomes 1.653389868. So that's what you have in the calculator, right? So we're going to divide both sides by that number, 33898. And I want you to use all these decimals because it just gives us a more exact value. 1.653389868. So we're going to divide 70,000, divide 71 to 3, divided by 1.653389868. That means that our principal, the amount of money we deposited, was $42,337.26. So that's how much money we started with. And again, we didn't leave the money in the account for too long. Okay, only 9 years. 6. So it's 2 problems. One is compounded annually, the other one is compounded monthly. So let's see what difference that makes. So 1,000. It's 1 plus. Let's do the annually first. So it's 0.08 over 1. And then 1 times 10, so just 10. The other one is going to be 1,000. 1 plus 0.08, but it's compounded monthly, so it's divided by 12. And then on top here will be 12 times 10, or 120. So that's the difference between annually and monthly. Okay, let's do the right side first. So it will be 0.08 divided by 1, which is 0.08, plus 1, enter. It's 1.08. We're going to raise that to the 10th power. And in your calculator, you should have 2.158924997, which you're going to multiply by 1,000. So after 10 years, this bank account will have $2,158.92. On this side, I'm going to do it again, 0.08. This time we divide it by 12. Enter, plus 1, enter. In your calculator, right now you should have 1.00 and a bunch of 6's, right? And a 7, raise to the 120th power. So let's raise it to the 120th power. Press that button, and then 120. And you get 1,000 times 2.219640234. You multiply that by 1,000, you get 22,100. Right, not 22,000. 2,119 and 64 cents. Okay. Seven. Somebody bought a condo, $110,000. It appreciates at 6% every year per year, so the house goes up. And then at the end of that first year, it goes up. So here's the house value. So it's 100,000 right now. It goes up to a certain value, and then it goes up 6% of the original value, and then it goes up 6% of this value here, right? And then at the end of that year, it goes 6% up at this value, and so forth and so forth. So it's compounded annually. So 1 plus 0.06 divided by 1, right, is compounded annually. And then on top, it's going to be 1 times the number of years. 2012 minus 2005 is 7 years. So we're going to put a 7 over here. So 0.06 divided by 1 is just 0.06. We're going to add 1 to that. And then we're going to raise it to the 7th power. And the number we're going to have here is 1.503630259. Now multiply that by 110,000. And our house value was 65,399.33. So in 7 years, a house that we bought for 110,000 is now valued at 165,399. So not bad. Okay. 8. What interest rate? Oh, so this is the tough one. So let's plug in our values. Our interest rate is going to be our unknown. So I want my bank account to have this much money at the end. I'm going to put $4,000 down. 1 plus the interest rate, I'm going to leave it at R. Compounded monthly, so divide that by 12. And over here is N times T, or 12 times how many years? 12 times 18. So 12 times 18, the number here is 260. So that's what that formula is with all the numbers plugged in. So rate is what we're trying to find out. A couple of things we can do. We can get rid of this 4,000. We can divide this by 4,000. And guess what? We can divide this side by 4,000. So these two will go away. I'm going to be left with 1 plus R over 12 to the 216 power. On the other side, 98,500 divided by 4,000 equals 24.625. Okay, so now comes that part. How do I get rid of this, right? This exponent of 216. I can take the 216 root of this. So I'm going to take the 216 root of that, and I'm going to take the 216th root of on this side. Okay, now we know that this and this will go away, finally leaving me without any exponents. I'm going to be left with 1 plus r over 12. And then on this side, you're going to have to figure out what number times itself 216 times equals to 24.625. Thank God we have a calculator, so we're going to press, remember, we're going to press second function. Actually, sorry, we're going to press, let me just, second function. Yep, so we're going to press, actually, first of all, you put in your calculator 216, then you press second function, and then you press this little button. And that, and in your calculator, this should be blinking right now. Okay, so again, enter 216, second function, that little triangle thing without the base, and this is what you should be seeing in your calculator. And then inside that radical, we're going to put the number 24.625, and then I'm going to put the number here, 24.625, and then we're going to press enter. And that's going to give us a very tiny number, 1.0149427776. Okay, so now it's just an equation. So how do we do this? Well, we're going to subtract 1 from this side. We're going to subtract 1 from that side, right? So these two go away, and here the 1.0149427776 subtracted by 1 is just going to give us 0.0149427776 equals r over 12. So we can put this whole thing over 1. We can cross multiply. R times 1 is r, right? And on the other end, on the cross, on the other cross, we're going to multiply 12 times that long number, 0.0149427776, and our final answer is going to be 0.1793. I'm just going to go a little bit more, 13312. So that's the rate, but it's in decimal format. But as a percent, we can move the decimal 2 over, and it's 17.93%. Okay, so if you have $4,000 and you want it to grow to 898,000, you're gonna have to find like a miracle fund or something that pays you 17.93%. Is it impossible? No, but is it really difficult? Yeah, because that's really, really high, right? So you gotta be super, super lucky, or just find a great fund. So that's the answer to that. Okay. 9. Adam does what? Again, same question, but different numbers. So he wants his account to show $18,624.97. He's going to put $6,139 in the beginning. 1 plus what's the interest rate? That we don't know. This is compounded quarterly or 4 times a year. Remember, the exponent is the number of times it compounded by the number of years, so it's 4 times 17. 28 was, so we're going to put 68 over here. The first things first, get rid of this guy, right? So let's get rid of this, right? And then I divide the other side by the same number. And 18,624.97 divided by 6,139 equals a very long number, 3.033. And I'm going to write all these numbers only because we want to be really precise. And we have a calculator anyway. And then on this side, equal 1 plus r divided by 4 to 68 power. So repeat the process. Take the 68th root on both sides. But that and that goes away, which gets rid of that exponent for us. So we get 1 plus r plus 4. On this side, What are we going to enter first? We're going to enter 68. So again, we press 68. And then second function. And then this. So 68, second function, that button. Your screen should have this blinking right now. And inside the radical, we're going to enter that number, 3.033876853. Enter, and we get this number, 1.0514632224. All right, so now things are really easy. Subtract 1 from both sides, -1, this guy, -1, oops, -1 here. So on the left side, we're left with 0.051463224. Here the 1s goes away. I'm left with r over 4. Cross multiply, and we get that r equals. So we're going to multiply r times 1 and r and 4 times that 0.051463 number times 4, and we get our interest rate as a decimal, 5852897. Let's move the decimal 2 over, and as a percent, 20 point, I don't know, we can round it now, 20.59. So we round the final answer. Okay, again, 20.59 it's a ridiculous number. So I should have made the question a little more realistic. But it can happen. It can happen. 10. What was the principal? So here I have 3,500 is what I have in my bank account. What did I start with? 1 plus 0.053. We're going to divide this by compounded daily, divided by 365. So on top here, it's going to be 365 times 10, which is going to give us 3,650. I'm just going to put that number right there, right away. All right. Let's see how much I started, how much money I put in my bank account. Left it for 10 years, compounded daily. So first things first, 0.053 divided by 365. Enter. Add 1. Enter. So we should have this number on your screen. 1 point, and we're gonna use that number 452.452.05 raised to the 3,600 power. So now press that button. 3650. Enter. And we have 3,500 equals P times 1.698866939. We're going to divide both sides by that ridiculous number. $1.698866935. 3,500 divided by 1.698866939. Enter. So I started my bank account with this much money, 2,060 and 20 cents. That's how much money I started with. Oh, again, another interest question. Who makes these questions? What do I have? Compounded monthly for how much interest was earned. Alright, so A, let's find the amount of money in the bank. So I put 175,000. The rate is 0.032. Compounded monthly divided by 12. So here on the top is going to be the number of times compounding, which is 12. Multiply that by 19. And we get 220. So A is, remember that A is the value, the amount of money in my bank account, which includes how much I deposit in the beginning, right? So this is a large deposit. So let's figure out the parentheses first. 0.032 divided by 12 equals 0.00266666. That's what you're going to have on your screen. We add 1 to it. So right now we have this number on our screen, 002, 6666, a bunch of sixes, and 7. We're going to raise that to the 228th power, so press this and then press 228. Press enter. So 175,000. We're going to multiply. The number on your screen should be this. 26848462. Multiply that times 175,000. Those of you who have that much money. So after 19 years, when you come back, you're going to have 321171, $321,171.98. But that's not the answer, because the answer says how much interest. How much did we earn? Well, it's going to be 321,171.98 minus what I put in initially. And how much money did we make? So that's 171,641. We made $146,171. We left that money for 19 years. Okay. Well, how much did you invest originally? Okay. So my bank account has this much showing, which is not that much, really. Principal, I have no idea. I opened the bank account 3 years ago, so it's 1 plus, what's the interest? It's accounted weekly, okay. Compounded weekly, annual interest rate of 4.35 or 0.0435. Weekly, remember how many weeks do we have in a year? 52, so we're going to divide this by 52. On top here, it's 52 times how many years? Times 3. Okay, which is 156. All right, so this one's not that difficult. So 2513.43 equals P. Let's figure out what that whole mess looks like. 0.045 divided by 52, enter. Plus 1, enter. So we're going to have this very ugly number, 0.0086538. And then we're going to raise that to the 156 power. So press this and then press this. And press the little triangle thing. And then 156. Press enter. Sorry. All that number simplifies to 1.14434699968. Alright, so divide both sides by that ugly number. Divide this side by that ugly number. 69968. These two go away, simplifies to 1, and then let's divide that. So 2513.43 divided by 1.144699968. Enter. That means I started my bank account, or I deposited initially $2,195.71. That's how much I started. So I made about what, $300? Yeah, $308 or something like that. All right. But again, I only left the money in the bank account for 3 years. How much? Again, another interest question. Ooh, okay. So, $8,000, $320,000 is what I want to have in my bank account. I put in $8,000 30 years ago, so 1 plus the interest rate. I have no idea what it is. Compounded monthly, so it's times 12. And over here is the number of times it compounded yearly, 12 times the number of years, which is 30. It's 12 times 30. 360. So that's what it looks like. All right. First things first, let's get rid of that 8,000. I'm going to divide both sides by 8,000. All right. So this is gone. This is gone. This is going to be 40. 1 plus r over 12, 360. We're going to take the 360th root on both sides. That goes away. That goes away. I'm left with 1 plus 12 on that side. We're gonna press 360, second function, triangle thing. So enter 360. That, sorry, 360. 360-second function, and then this symbol, and your screen should have this right now. And then inside of that, we're going to put the number 40. Click enter. We have this number here, 1.010299567. We're going to subtract 1 from each side, minus 1 here, minus 1 here. So let me write what I have left over here. These two ones is 0. I have r over 12, and then on that side, I'm left with obviously 0.010299567. We can cross multiply. Remember, there's a 1 over here. So the r is easy. R times 1 is 1, and then I'm going to multiply that by 12, and I get. Oh, I erased it. 12 times 0.0, 12 times 0.010299567, and I get my interest rate. 0.123, 123594. We're not gonna need all those. Now round. Finally, we can round 2 decimal places. That becomes 12.40%. All right, that's tough. 12% a year. Not easy. If you can find something that earns that, and if you put $8,000 today, and you find something that pays you 12.40% every year, compounded monthly, you come back to it at 30 years, you'll have $320,000. Okay, so yeah, that's it. Once you understand how the formula works, it's really just understanding again how to use a calculator. But that's it. All right.